Hello friends, how are you? Hope you guys are all well. Welcome to my YouTube channel. Today my topic is about networks and fuzzy logic. That what it is and everything about it will be discussed in this video, and your doubts will be cleared in this video. So please, I request you to subscribe my YouTube channel and don't forget to watch my previous videos. So moving to my topic. Maps were the original spatial databases, but they were not so good for updating and analyzing. Crunching members, we now use computers because they are fast once we have the data in the proper formats. Accurate plotters, digitizers, and relatively cheap. Computers were expensive in the past and labor was cheap. Now computers are really cheap while labor is expensive. Computers allow more flexibility. Different versions may be produced and you are able to choose the best one. We have to tell computers how to perform most of the interpretations of maps that humans do that lead to ways to represent and model reality. The thing interference, we must define all terms and features, quantify at the start of the teaching process is the requirement that we operators decide how reality is going to be modeled. The spatial database section of this course outline that discusses the overall concept of the modeling spatial data. Here we will cover the raster and the vector data models in more depth. Okay, after that you can see that the vector data model, that what it is. The American Heritage Dictionary defines a vector as a mathematical concept wherein a quantity is qualified completely specified, a magnitude and a direction. In surveying, a vector can be thought of as where we go when following a certain azimuth for a certain distance. A vector storage, the basic unit in vector storage is a point. Connected points make lines. Lines may enclose a polygon. Vector storage is the object based. It tends to store geographic features as objects. Say that a line is stored sequentially in the database. Vector storage mimics the manual method. It will digitize similar to the way that we draw maps. It is important for objects in features to be in order, such that points and segments. The order of the objects is not important. Such that one line before another is not important. A discrete data model specifies the distinct location and has specific edges. Change is abruptly, hence discrete. Emphasis is on the entity. Location is an attribute, and the location of the entity must be stored. Adjacency is not inherent in a vector file. A typical file tells nothing of what is next to what. We need topology for this. After that, stored by the object, a finite numbers of locations are defined by the objects. This method only deals with the locations where a feature of concern is vector precision. Vector precision is encoded with any conceivable degree of precision. Precision is limited by the method of the internal representation of coordinates. Decimal digits. Precision is actually measured in significant digits. Auto CADR is doubled precision. Arc CADR is single precision. Arc infer is double precision. Limit precision to 1 over 108 or 1 over 1016 of the size of the study area, and equivalent raster would need 108 by 108 or 1016 by 1016 cells, neither of which is feasible. Note there may be an artificial argument because real vector data accuracy may be much worse than one line width. After that, soil and vegetation types, etc. have fuzzy boundaries. It can be argued that the fine lines of the vector systems give a false sense of precision and accuracy. Lines on the map are typically 0.5 millimeter wide and are often assumed to present uncertainty in the location of the sub-object. In raster-based maps, uncertainty is automatically reflected in the cell size. That precision allow a cheap concept of accuracy and precision. The types of the files that have been used over time for storing polygons. The location list is a response to the original line plotters. Okay, so I have think that you have understand what I was trying to teach you. So meet you in the next video. Goodbye.